everybody, and welcome to another episode of Constant Science. I'm Don from Explosions Incorporated. Like I said last week in my Dive Science video, I'm going to do another installment of Minute Chemistry this week. For those of you who haven't seen that one or forgot already, losers, Minute Chemistry is my attempt to go over every single element in the periodic table 1 minute at a time, just to give you some information, some relevant facts about all of them. And it's going to take a while, so I'm not going to do it all the time. We'll just get through it bit by bit by bit. It also is a challenge for me because I tend to talk a lot. So here we go. This week we're starting with element number 6, going all the way to element number 10. All right, let's get that timer started. Element number 6, carbon. 6 protons, 6 neutrons, and 6 electrons. Carbon is the backbone of all living things. It is necessary for organic molecules, although not all molecules that contain carbon are organic. Some of carbon's most common and recognized forms are coal, diamonds, and graphite, which you write with in pencils. And then there's also graphene, which is really cool. A super thin sheet of hexagonal bonded 6 carbon atoms, one on each side. You get a really big sheet and super duper strong, and you roll it up, and you can make this thing called a carbon nanotube that is super strong, tensile strength, like 100 times stronger than steel cable, and we can possibly build a space elevator out of it, and that's really neat. Carbon nanotubes are also found in Damascus steel, that stuff that we don't even know how to make anymore. They used to make it, and somehow they ended up with carbon nanotubes. Carbon is the 4th most common element in the entire universe. It's forged in the hearts of stars in what's called the triple alpha process, when 3 alpha particles, helium nuclei, all bam, bam, they hit each other at the same time, and they fuse into one single carbon atom. That's pretty cool. Number 7, nitrogen, 7 protons, 7 neutrons, 7 electrons. It's also 77% of the Earth's atmosphere. That's right, most of what you breathe isn't actually oxygen. One of the most common compounds of nitrogen is ammonia, which is extremely basic and caustic and nasty and poisonous, but it's a really good cleaning product. You may recognize it from ammonia bleach. Like so many other elements, nitrogen is formed in the hearts of stars by stellar nucleosynthesis. It has many different uses. We can use it in light bulbs, in tires, and things that need to be inflated and not oxidized. If you fill those things with air, the oxygen inside them can oxidize the stuff and possibly cause damage. So anytime you don't want something to oxidize, nitrogen is a good alternative. When you cool it down a whole lot, you get liquid nitrogen. You can do cool stuff with it. Aaron and I like liquid nitrogen. We also like another product of nitrogen, nitrocellulose. You take cellulose, you dip it in nitric acid, some other stuff, and you end up with this. And finally, you do need it for your amino acids and your nucleic acids in your DNA, so you could not exist without nitrogen. Number 8, oxygen. 8 protons, 8 neutrons, and 8 electrons. We breathe oxygen. It's only 21% of the Earth's atmosphere, but that's a pretty good thing, actually, because oxygen, as you may have surmised by its name, is a very strong oxidizing agent. It likes to take electrons from other things, thus oxidizing them and itself being reduced. So rust is an oxidation process, and binding with hydrogen to form water is an oxidation process. Fire, combustion is a type of oxidation reaction. So aliens may actually look at our planet and go, look at all that oxygen. Nothing could possibly live down there. They're surrounded by this incredibly noxious oxidizing agent. Oxygen is formed in the hearts of stars as an occasional side effect of the carbon synthesis I talked about earlier. And even though we do breathe it, you don't want much more than that 20% mixture. You can actually get what's called an oxygen narcosis, which can negatively affect your nervous system and lead to even seizures. So those oxygen bars that you see at like casinos in Las Vegas and stuff like that are kind of useless and potentially dangerous. Number 9, fluorine. 9 protons, 10 neutrons, 9 electrons. Fluorine is the most reactive element on the periodic table. It reacts with almost every other element. Stable fluorine is not created in the hearts of stars. Fluorine can be created, but then it is immediately turned either into oxygen or into neon. So we're not sure where stable fluorine has come from. There are some hypotheses, maybe in type 2 supernovas or maybe Wolf-Rayet stars. Actually, their solar wind pushes it away before it can get converted into neon or oxygen. There are lots of different uses for fluorine and fluorine compounds. Teflon non-stick surfaces, the original non-stick surface, and Gore-Tex, those are fluoride polymers. And then of course there's the fluorine ion, is what we put in fluoridated water because it's really good anti-cavity, perhaps the cheapest and most effective medical intervention in the history of the 20th century. It can be really poisonous, and so people are worried about fluoride in the water. It's in half to 1 part per million in the water supply, and it can be very poisonous in levels of 25 parts per million and above, but we're not anywhere near there in the water supply, so don't have to worry about that. Just don't eat your toothpaste. Number 10, neon. 10 protons, 10 neutrons, 10 electrons. Neon is the very first of the noble gases. It is inert like all the other noble gases. It does not form compounds except when it does. There are standard conditions under which the noble gases are inert, but in super high energy situations or there's way too much pressure or something, sometimes noble gases do in fact form compounds. Neon has a very characteristic orangish red glow when you energize it. And so when you see a neon sign, the orangish red, that's the only type that's an actual true neon sign. any other color has other elements mixed in with it. Other gases light up different colors when they're excited by energy. A neon's actually fairly abundant in the universe. It is, of course, formed in the hearts of stars. It's the 5th most abundant element in the universe, but there's not a whole heck of a lot of it here on Earth because since it doesn't bond with things, it doesn't form compounds, so it can't get fixed to solid matter and hang around in the soil like so many other elements can. So there's some of it in the atmosphere, but most of the neon that's out there is kind of floating out around in space. Even Jupiter doesn't have a whole heck of a lot of neon, and it's a gas giant. All right, everybody, thank you for running through elements 6 through 10 with me today on the second installment of Minute Chemistry. I do like this. I learn something new every time I do this. It's kind of fun. I have to talk really fast, and I hope you're learning something cool from these. Our last Minute Chemistry got a lot of views, a lot of hits, more so than our normal videos tend to. So yeah, thanks for watching, and I'll see you back for our next episode of Constant Science. I'm Don from Explosions Incorporated.